Today we're talking about analyzing tables and graphs and looking at two different data sets in addition to two different types of data portrayal, and using that information in order to make an informed decision about the issue at hand. So the question that we're looking at says that tour operators decide to rent bicycles for their customers. They get information from two bike shops. Rocky's Cycle Center sends a table of weekly rental fees for bikes. So the number of bikes and the rental fee per week. So Adrian's Bike Shop sends a graph of their weekly rental fees. Because the rental fee depends on the number of bikes, they put the number of bikes in the x-axis. So there's two different sets of data here. And what I'm going to do is I'm going to combine that data so that I can look at it in one medium and view all that information. So I insert my guidelines, and what I'm going to do is look for my first coordinate point with the Rocky's Cycle Center data, and that has a number of bikes of 5 and a rental fee of $400. And as we progress, we can plot every further data point in the table. We know how to do this. It's 10 bicycles for $535, 15 bicycles for $655, and etc. So you may want to pause here for a second because I did skip ahead so that we can finish plotting that data. I'm expecting you to be able to plot a coordinate point at this time, so this is not something that we need to review. However, once all of our data is plotted, you want to make sure you identify a key for that data. So notice how the original data that I had on Adrian's bike shop was in black coordinate points, and when I added the data from Rocky Cycle Center, I used blue coordinate points. So I'm just going to go through and make sure that I labeled those colors and that people are aware of what color represents which bike shop, and that way our data is very clear, and we can refer back to it when we need to for some discussion questions. So the first discussion question that we have is, which bike shop should the tour company use? Which bike shop? So really, what's going to be the cheapest bike shop? If you take a look at the coordinate graph, now that we have all the data in one place, we can compare where the data falls. Now our cost is on our y-axis, so I drew in my guideline on the y-axis, and I just dragged it across my coordinate grid until the point where the trend of my data was not constant anymore. So up until this point, the Rocky Cycle Center has been at a higher point than Adrian's, meaning that the rental fees were more expensive. But once we reach about 35 bicycles, these data pieces switch places, and what I'm doing here is just connecting my coordinate points. So it's a little easier to see this, where the data kind of overlaps one another and goes in different directions. So at less than 35 bicycles, Adrian's bike shop is actually cheaper, but once we look at greater than 35 bicycles, it looks like Rocky's bike shop is cheaper. So that's the statement that we're going to have to make in order to answer this question correctly. On the previous page, it does not tell us how many bicycles the tour company is looking to rent. It just says what bike shop should they use. So you do need to identify both of these situations, that if it's less than 35, they should use Adrian's bike shop. If it's greater than 35, they should use Rocky's bike shop. And I'm using my less than and greater than symbols here, so I hope that that is clear when you're reviewing these notes. So the next question says, suppose you make a graph for Rocky Cycle Center. Now, lucky for us, we already did this. We did that tool in order to be able to better observe the data. And it says, does it make sense to connect the points? Explain. Now, our basic rule of thumb is that you only connect points on a coordinate graph if x is your independent variable, and your independent variable is time. So you can only connect data points when x is your independent variable of time. Now, in this case, we did go through and connect our data points. That was strictly for a visual for us to be able to solve the problem, but I would expect you to go back and erase those lines on a test or a quiz because they're not really called for in this type of data. Okay, so we'll go back and we'll erase those lines. The next question says, how much do you think each company charges to rent 32 bikes? And I'm going to do this by going back into my graph and shifting my guideline to the point at which I think it's about 32. Now this is actually kind of silly because what we need to do, there's not an actual data point on 32. So we do need to connect the data points surrounding 32. So from 30 to the 35 mark, we're going to connect the data points for each set of data. So obviously the data points from Rocky's data and the data points from Adrian's data. And what we're going to do is where the line that is connecting our two data points intersects our guideline at 32, that's going to be kind of a makeshift coordinate point that we can work with. So we are kind of plotting those two new points, one being Rocky's data that's about $1,000 and one being Adrian's data that's about $900, maybe $950. So we can go ahead and write our answers down underneath that question. And as we progress, the next set of questions are kind of redundant, but there is a purpose for them. They said, describe a way to find the costs for renting any number of bikes from Adrian's, and then, describe the way to find the cost for renting any number of bikes from Rocky's. Now, this is kind of the question that we just answered. We were connecting our coordinate points to use as a guideline in order to go back and then use that vertical or horizontal guideline and find a new coordinate point, estimate the location of a new coordinate point. And this is going to be the same response for both Adrian's data and for Rocky's data. This is only the same response because we did copy the data from Rocky Cycle Center into a coordinate graph. If we had left it in a table, we would have had a different answer. We would have had to said something like, oh, you could have averaged the data and found a midpoint or compared it that way. But since we did put it on the coordinate graph, these could be the same answers. And it says from there we can estimate the location of a coordinate point based on the variable that it gives us. So if it says you want to rent 12 bikes, we can estimate the cost. If you want to rent 50 bikes, we could still estimate the cost. Our limitations are the minimum number of bikes we can estimate is 0, and the maximum number of bikes we can estimate is the data that's actually on our graph or our table. So I think for both sets of data, the maximum number of bikes we can estimate is 50. Okay? So the key point to today's lesson is being able to interpret multiple means of data, tables and graphs, into one situation and make the best judgment for that situation.